My timeout caught up with me there. Was my... Dang it, my stylus. Yeah, so my... I got a 10-minute timer, and I didn't notice it coming up on me there. Hey, we just found the second derivative was negative, since r double prime is always negative. Any critical point is the global negative is... No, negative is concave down, is the global max. Let's find a critical point. When does the derivative equal 0? The derivative is 200 minus 0.09 q squared. When do you equal 0? That's when 200 equals 0.09 q squared. So q squared is 200 divided by 0.09. That's 200, multiply top and bottom by 100. So q is the square root of 20,000 over 9. There's a negative solution. I don't care about the negative one. Like, I'm remembering it because that's the correct thing to do, but then immediately throwing it away because we don't care about it. Yeah, that's our maximum. Write a formula for the total revenue function. We did that. Find what the maximum possible total revenue is. So we found what quantity causes the maximum revenue. We haven't found what actually is the maximum revenue. So let's find that out. To find the maximum revenue, I need to take that number and plug it into 200 minus... Yeah, I need to plug it into the revenue function. Let's do that on the calculator. We're going to do that using the answer key because that lets us not have to type in that gross number that much. I want to know what's the square root of 20,000 over 9. And now my revenue function is I want 200 minus 0.03 times that answer squared times q. Q is that answer. This is 6285.39. So R of this is 6285.39. Cool. And I have my sentence that says why I know this is the maximum. Oops. I leaned on my volume key on my headset. Here's a graph. We have a cost function at a production level of 300. So here, should we increase or decrease production to lower our average cost? So this is asking us to do the same average cost versus marginal cost. Which of those is better? So I'm comparing two slopes. The average cost is draw the line from 0, 0 to that point, is this line. The slope of this line is the average cost. Compare that to the marginal cost. Marginal cost is the derivative, is the tangent line. Here the slope is the marginal cost. And I haven't drawn these very well, but I don't have to draw them very well to see that this one is bigger, or that this line is flatter than that line. The average cost is greater than marginal costs. So, what does this mean? It means the next item we produce will cost, the marginal cost is less than the items we have already produced. The next one is cheaper than the ones we've made. So the next one is a good deal. So we should increase production. To lower average costs. Check. Approximately what production level minimizes our average cost? So this is one where I need to hold up a ruler. And I don't have a good way of showing what I'm doing with my clipboard to you. But I'm fixing one end at the origin. One end of my ruler is fixed here, and the other end I am tilting down as far as I can. And how far can I tilt it down and still hit the graph? Like I can draw, this line is hitting it twice, I can tilt it a little further. This line is hitting it twice, I can tilt it a little further. How far down can I go? The lowest I am seeing is like right here. The line came out a little bit lower than what I was looking at. This was the last point I was able to see. Looks like the average cost is minimized at Q equals, what is that number? 785-ish? Clearly indicate what you're seeing that makes you give that response. So that's saying draw this line. You don't need to draw these lines that I was trying to use to show you what I'm doing. The line that hits that one is the important one. Cool. So we should increase production from 300. And that turned out to be correct because the minimum was at 785. Cool. I've worked out that the sales of my shirts have an elasticity of this. If I usually sell 500 shirts a week, I'm overstocked and I'm thinking of running a 15% off sale next week. If I did, how many shirts would I sell? So this is about thinking about discrete elasticity. The thing elasticity is, it's negative, percent change in quantity divided by percent change in price. And that 15% off is telling me that, so you want to do a percent change in price of negative 15, eh? So elasticity, which they told me was 0.8, is going to be negative the percent change in quantity. We don't know how sales are going to change, but we do know the price is going to be negative 15 down. So these negatives cancel. To get the percent change quantity by itself, we would multiply both sides by 15. So the percent change in sales, come on, stylus. I fix it. So the percent change in sales is going to be 15 times 0.8. What's 50 times 0.8? It's 9. So sales should go up by 9%. We haven't done anything deep. It's just the E of 0.8 says that the percent change in price, you want to go down by 15. This one will be 0.8 of that. 0.8 of 15 is 9. Sales should go up by 9%. That's not exactly what they asked us, though. They asked us, how many shirts will I sell? Well, I usually sell 500. If it goes up by 9%, what's 9% of 500 is 45? So an extra 45 sales, 545 for the week. Cool. I'm almost out of time. Yeah, I can't do this in a minute.